Welcome back, everyone, to another session of Big Data Days 2022. Sorry about that. So before I start this session, um, just a couple of things that I would like to mention to all of you. So feel free to use the question box on the right-hand side of the screen to ask as many questions as you want, because this session is going to be a very interactive session, which the speaker will actually show an actual demonstration of AWS. Okay. So it's my pleasure to welcome Paul Colmer. And let me give a brief introduction about Paul. Working for Amazon Web Services as a senior technical trainer with a specialism in machine learning, Paul loves sharing his passion and knowledge to help customers grow. In this session, Paul will outline a broad range of features and use cases for Amazon SageMaker, culminating in hands-on demonstration of a low-code offering called Amazon SageMaker Autopilot, which will show how to automate parts of the machine learning lifecycle. So Paul, whenever you're ready, the floor is yours.
Thank you so much, Jeremy. Just to make sure you can all hear me.
Yep, can hear you loud and clear.
Fantastic. So thank you so much for the introduction and welcome to you all. So we're going to have a bit of fun today. Like Jeremy said, please feel free to ask the questions in the chat, which is over to my second screen over here. So feel free. Welcome to you all. I can see there are 9 people in the session. And what we're going to do today, we're going to do a little bit of a demonstration, a tiny bit of PowerPoint and a little bit more demonstration. We'll start off sort of non-technical and we'll sort of get deeper as we go through. So as Jeremy said, my name is Paul Colmer. I am a senior technical trainer at Amazon Web Services. I've been with them almost 2 years now and been really enjoying my journey. I was a technical account manager prior to being a trainer. And then prior to joining AWS, I was a trainer for a number of years, a freelance trainer. So glad to have you all on this fantastic conference. And I hope you enjoy the little tricks and surprises I've got for you. So the first thing I'm going to do, I'll just share my screen. And what you should see is my console. So this is Sagemaker Studio that you're looking at the moment. So what I'm going to do, normally with this type of demo, you would go to the top search bar and you would just simply type Sagemaker and click on the Sagemaker link. It would take you to this page. You would then click on Studio and then you would click on Launch Sagemaker Studio. So Sagemaker Studio is our integrated development environment for all things machine learning. And when you first come to this screen, you will then have to create what's called a domain, which is just a collection of objects and a collection of users. And I've already created one here previously. So I'm just going to go down and launch my version of Studio just in a new window for you. So over on this window here, I now have Studio loading. That's going to open up my domain and open up this particular user. And I'm going to take probably, hopefully 3 or 4 minutes to show you how to use SageMaker Autopilot. So this tool will allow me to run a number of machine learning models, and hopefully we will finish up the models by the end of this talk. That's the plan, and I can show you a little bit more detail around that. If they don't finish, I do have some I prepared earlier, but we'll hopefully, fingers crossed, they'll finish in time. So what you're seeing on the screen now is you're seeing what's called a Python notebook. So it consists here of what we call markup language. And if I scroll down, it consists of Python code. We'll look at this towards the end of this talk. So this is a bit of a tease really for you. This is the bit where I'll talk through. I'm not going to talk through every line of code, but I'll show you how simple it is to use SageMaker Autopilot using what we call low code. But what I'll do now is show you how to do it with no code. So we go File, New. I go down to Experiment. Now I'm going to give it a name. So what's today's date? 25th. So I'm going to call it Test. 25th of May 2022. I need to enter what's called a bucket location. So S3 stands for Simple Storage Service. And I have some data that I've prepped previously. Now you can prep the data using Python code, and I will show you at the end of the demo how that works. but you can also prep using something called Sagemaker Datawrangler, which is our no code offering. And so if you wanted to, you could manipulate data using that. I've chosen to manipulate it by code, and then I'm just pop the data into my S3 bucket. So what I'm doing is I'm actually starting an autopilot experiment. So you see at the top, autopilot experiment. I have to specify my source address where my data lives. Hopefully it would have read the data correctly, and it has. And it knows all the different features of my data. And I happen to know that churn, so this is a binary classification problem. So churn is the field I want to predict. I'll explain what churn and all these things mean a little bit later, but I just want to kick this demo off just so we get something we can show you. Next thing I do is enter the output location. It can automatically detect the problem type. So you see I've set to auto, or I could tell it it's a binary, a regression, or multi-class, but I'm going to set to auto. And so that's one of the great features of Sagemaker Autopilot is it can automatically detect, as long as it's one of those three types of algorithm or three types of machine learning problem, it will automatically detect it. Do I want to run a complete experiment? Yes. Do I want to auto deploy? On. So I'll actually show you the endpoint that's running at the end of this. And that endpoint is what you will use to run your inferences on. So I'm just going to give it a name. I'm just going to call it my best model, 25th of May, 2022. Now, I need to go into advanced settings here. You'll see why in a moment. I'm just going to leave all the defaults, but I can run a number of experiments simultaneously. Now, the default is 250. So if I was to click create, it would run 250 experiments. I actually only want to do 5. One, I want to control my cost, and 2, I don't have time to run 250. It will take a bit longer. So with a bit of luck, we can create experiment and we can confirm. Fingers crossed. Let's hope the demo gods are working. So that's how easy it is to start a machine learning experiment. So what it's now doing, it's now analyzing my data source. It's doing some pre-processing tasks, as you can see here. It's going to then decide on 5 candidate pipelines. So they're effectively 5 candidate models it's going to start with. And then it will run those 5 models. It will then feature engineer those models. So it makes sure that the data's spent to training and test sets. It will tune the model automatically. It will give me 2 types of report that I'll explore if we have time. And it will deploy the model. And it does all that with those few clicks. So there are some prerequisites. I had to make sure the data is in the right format, and I had to make sure the data was clean. And even though Autopilot does do some cleaning, it has to be reasonably clean, and then Autopilot does the rest. So that's how you would do a machine learning experiment. So run a number of models, and then it will automatically pick the best model for me. And that happens all under the hood, and you saw how easy it was. I will show how to do that with some code after we've done some PowerPoint. And feel free to ask any questions at any time. Wonderful. So let me go into the PowerPoint. So that was using a product called Amazon SageMaker Autopilot. So what we're going to do now is we're going to go up a bit of a level and talk about Amazon SageMaker. So Amazon SageMaker is our suite of machine learning offerings. And Amazon SageMaker Autopilot is what I've just demonstrated for you. And there's a number of different features in SageMaker, a number of different services. We're not going to walk through them, all of them, but I'm going to give you a bit of a taste of them. But let's take a step back. Let's talk a little bit about how we ended up talking about machine learning, I guess, in the first place. So machine learning has really started as an aspirational technology. And it's only in recent years it started to become in more mainstream. So for a long time, the technology has been limited to a few major tech companies. And it's a great privilege to really be sharing the AWS technology with you all and helping clients on their journey. And this is what's so exciting. So we see things like, increased spending, which is one defining moment, I guess, in terms of what we're seeing with AI. So increased spending. We see more organizations move from pilot phases to industrialization or I can't even say it, operationalizing phase. I've got it out eventually. And the other thing that we're seeing is we're seeing AI transformation. It's transforming our lives. We're seeing some of the applications, such as in driverless cars. We're seeing things in terms of call center automation. And that's where the AI transformation is really coming in. But what really is machine learning? Let's take it up a level. Let's talk about AI to start with, artificial intelligence. So AI is a technique where we can use computers to mimic some of the cognitive functions of humans. So a good example, one of my favorite is the self-driving car. So we use AI now to help cars navigate the roads, help them detect signs, help them understand speed, and that's all done with AI technology. Many AI systems today rely on a combination of machine learning and deep learning technologies. So machine learning is really a subset of AI, and it's the underlying technology powering many intelligent systems. The way to think of ML and DL, or machine learning and deep learning, is one is a progression of the other. So machine learning was very popular around the 70s, 80s, 90s, and then deep learning is a more modern set of disciplines. And essentially, deep learning is comprised of using multi-layered neural networks. So where we talk about neural networks, we're talking about deep learning. Where we're talking about random forest algorithms and naive Bayes algorithms, we're talking machine learning. So machine learning broadly is more mathematical algorithms, whereas deep learning is more multi-layered neural networks. But machine learning is no stranger to AWS, and it's no stranger to Amazon. Amazon is one of our clients at AWS. We treat Amazon as a client, even though we're part of the same company. They're very much a integral part of what we do. And as a customer, they use a lot of machine learning. So we've been supplying machine learning, such as areas such as personalization and supply chain, for more than 20 years. So if you like, we have been utilizing our technology that we've been creating. We've also improved the original personalization model significantly, and you can use AWS Personalize as one of our AI services. We use machine learning throughout the entire fulfillment process. So you see the example here of products being sold, being able to deliver 1.6 million packages every day. That's only possible with automation, and a big part of that is machine learning. We've also developed natural language processing technology to give customers an entirely new way to interact with technology through Alexa. So that's shortened to NLP, natural language processing. And we've also developed groundbreaking technologies such as autonomous flight through Prime Air delivery. So autonomous systems are also a big focus of machine learning. Let's have a look at the AWS machine learning stack. And we can divide the stack into three components. The bottom component is really around expert practitioners and how they can develop on the framework of their choice. So as you see at the bottom, we support PyTorch, Apache MXNet, TensorFlow as some of the examples. We also have the use of AWS deep learning AMIs, or Amazon Machine Images. The middle layer is really what we're demonstrating today with Amazon SageMaker. So there's really three components here. There's a SageMaker Canvas, which is designed for business analysts, and it's a no-code machine learning engine. It's all visual. We then have SageMaker Studio Lab, where you can learn machine learning. And then what you just saw at the beginning of this demonstration was you saw the skin that you saw was the Amazon SageMaker Studio Integrated Development Environment, or IDE. And what we saw throughout that Autopilot Amazon SageMaker Autopilot demo was you saw a little bit of a notebook. You saw it train the model behind the scenes. It's going to automatically tune and automatically going to deploy. It actually does detect bias for you in some of the explainability reports, but I still had to prepare the data, and you can use something called Datawrangler to do that. So that's some of the things that you've seen. And then the top layer of the stack, the AI services. These are the These allow developers to easily add intelligence to any application without needing heavy machine learning skills. So many of these services, you can look at many of these services, like for example, Amazon Kendra or Amazon Lex. In Google, just type Amazon Lex getting started, and you'll see a very simple way of getting started through the console. So all these AI services can be utilized through the console. But also, as a developer, you can access these services through the APIs too. And that's where a lot of the power over the AI service come from. But like I said, ML services is where we're going to focus today. So you can see we have a very, very broad and very complete set of machine learning capabilities. Those that are familiar with machine learning will understand that machine learning development is complex and costly. So there's lots of things that we have to do. We have to label our data. So that data was pre-labeled. We have to collect and prepare that data. Well, fortunately for this demo, it's been done for me. I will send you the link in the chat to the demo itself so that you can try the demo out for yourself. There's a feature store in SageMaker, allows us to store and reuse features. We might have a very large and diverse data science team. And we want to be able to pick and be able to help others reuse those great features that we found. We're not doing that today. Checking for bias is something that's important. SageMaker Clarify is our tool for that. We can visualize in notebooks, pick our algorithm, train our models, tune parameters, deploy, manage and monitor CI/CD. There's a lot to consider in a machine learning environment. And as I was alluding to there, Amazon SageMaker is built to make the machine learning models and the machine learning lifecycle more accessible. Very, very important. That's what it's really about. That's why we have these low code, no code offerings now. We're trying to bring machine learning to everybody. It's really, really important. And so SageMaker can cover all these aspects, labeling data. So there's a product here called, excuse my really bad writing, Ground Truth, for labeling data, for example. Checking bias, we have SageMaker Clarify. Very difficult to look at the camera and draw at the same time, I'm afraid. And then we can tune parameters, and we'll show you that in action with the model, and then we'll deploy in production. We'll show you how that works. And so, like we said before, this is the layer that we're looking at. But before we move on back to the demo, I know you're itching to get back to the demo and see how we're progressing, but I will turn back in a moment. Let's talk a little bit about customers. Customers are really important. It's why we're here. It's why AWS is here, to serve our customers. So we see machine learning now happening in a number of different areas. We see it in healthcare and life sciences. We see it in industrial manufacturing, financial services. We see a high adoption of machine learning now to try and predict outcomes. Retail, media, entertainment. Obviously, in the retail space, Amazon has been doing a lot of work, but we also are starting to see adoption of machine learning in lots of other areas, and these are probably the hot areas at the moment. Why should you worry about AWS? Like I said, we have the deepest and broadest set of machine learning capabilities. They're designed to take care of what we call the undifferentiated heavy lifting. So that's the infrastructure and all the things underneath that you really don't need to manage. They're the things that do not differentiate your business, and they're things that we do really well. So we want to take those and make that easy for you and automate that. But also, a number of things. We've got some proven use cases and industry solutions to solve business problems. We don't have time, but there's something in the tool called a quick start. So there's a number of quick starts which are ready to go machine learning solutions tailored to businesses. So there's a fraud detection, for example, solution that you can start very quickly. We talked about AI services with no ML skills. That was in the top layer. Talent is a huge issue, which is why it's so important and really great that AWS now is looking at no code and low code solutions, because if we can commoditize machine learning and make it simpler, we're not relying then on talent. We still need talent. Don't get me wrong, we still need data scientists, but wouldn't it be great if we can land to focus on the heavy, the mathematical side, the data side of things, rather than the actual undifferentiated heavy lifting, like training models and running experiments. As you can see with the tool, it does a lot for you. The Sagemaker Autopilot, and integrating with current infrastructure. So a few good reasons why you should look at AWS. Let's look at some customers. What are customers doing? They're doing great things. Intuit has built forecasting capabilities to predict call center demand on a particular day or time so that customer service agents can be adequately staffed. So they're using predictive analytics to understand what their resourcing profile is over a period of time and make sure they have the relevant staff ready to take calls. 3M, they're using our intelligent search solution, Amazon Kendra, and it's helping scientists find the information they need by handling natural language queries quickly and accurately. We've then got Kosh AS and Energy Solutions. They're improving asset performance by using something called Amazon Monitron and Amazon Lookout for equipment. So very much in the process control space. So detected normal equipment behavior and enable predictive maintenance. So when does the equipment need servicing, need maintenance? Can we predict when it will break so we can fix it proactively prior to that? And then my favorite, the NFL. So that's in sports. NFL are creating a next gen stats that engage fans by combining old and new data to reveal insights about game dynamics. And that data and that visualizations are being used to engage the fans either online or live on the television. So it's a great customers doing some incredible things. And now one of my favorite customers. Of course, I love many customers I work with as a trainer and as a technical account, previously as a technical account manager. But the reason Domino's is one of my favorites is because it's based in Brisbane and I live in Brisbane, Australia. So they're one of the largest pizza chains in the world. They're based in Brisbane. I'm a big fan. I like pizza. I think many people do. They have 2,600 stores globally, and they wanted to reduce their pickup and delivery times for online ordering as demand increased. So trying to anticipate the types of pizzas and the types of flavors that people would want on a particular day or a particular evening. And they're using key order data that they store in their data lake, which is really important. They want to remain a leader in a very, very competitive fast food market. Fast food, food generally is incredibly competitive. And so they want to improve that customer experience. We often see that time and time again. It all comes back to the best customer experience. And research indicate the sooner that Domino's can deliver a pizza, the more satisfied customers are with their meal. So really high customer satisfaction scores. Excellent. So that's the presentation. We'll flip back to the demo now. I can see there's some questions. I'll come back to those questions. So what you see on the screen, you see Sagemaker Autopilot. It's done its pre-processing. It now has its candidate definitions generated. It's working on feature engineering. And we're at 23 minutes. So we're not looking too bad. It may be done by 35, 40 minutes, but we'll see. But while that's working away, I'm going to just click onto this Python notebook. So the first thing I want to do is copy this link. In fact, I'll click on it. This is the original demo that you can all try. I'm just going to pop this into the chat. Hopefully you guys can see this. Everyone can see this. I don't know if it'll pop into questions as well. Let me try. I'll put the question there as well. Does that work? Yeah, it does. So feel free to take note of that link. So the demo that I'm going to show you now with low code. So I've already showed the no code demo. The demo I'm about to show you is from this link here. And I'll also show you I'll pass on to you as well the no code demo. So that was the very first thing that I did, Amazon Sagemaker Autopilot. I have to have some data prepared. All about sharing. You'll have a lot of fun with these. I had a lot of fun. Let's have a little look at some of the questions. Great question. Thanks, guys. Thanks, everyone. Considering to learn machine learning, any training you would recommend? Yes, so we have a site called AWS Training. You can just find that site, and within that site, there's a platform now called Skill Builder. So there's a practical machine learning plan that you can subscribe to, and it's all free e-learning. So that's a really good tip. Let me just see if I can dig out the link for you. The trouble is the link I'll send you will be the link I've got internally. But basically, if you take this link, let me just come back. Here we are. That's a link to the AWS training site. If you just follow your nose, there's free training on that site. It will take you to Skill Builder. Cool. So I hope that answers your question. That's the first question. What's the best way to learn machine learning? Same question, yeah. So I think through the training, AWS training platform and Skill Builder. Another way as well that's outside of AWS is Coursera is really, really good. So I did the John Hopkins Uni practical. There's a number of data science modules, but I think it was practical. I think it was R programming. It's really, really good. I know a number of people have done that I work with. Really, really good. That's sort of general machine learning, whereas the AWS is speaks to AWS. Question 3: how can you prevent ML bias? Great question. So the first thing about ML bias is understanding that you have bias. So very simply, what SageMaker Clarify can do, it analyzes your data, and it will look, for example, to see how certain fields are balanced. So an obvious one is male and female gender, and so it will show you what the balance is. Is your data heavy in male? Is your data heavy in female, or is it nicely balanced? And so you can see by those visualizations whether that data needs to be recast, or whether you need some mathematics around it to try and remove some of that bias. But that's a really good question. Bias is a real problem. It's very, very important. Do you think ML or AI will take over most jobs? I love that question. It's probably one of the questions I've asked an awful lot. I think what we're going to see over the next 10, 20 years is a transition. So a transition into, I guess, a new age of skills. And so instead of a lot of manual tasks, we're going to see a higher level of automation. So just like, for example, in the DevOps space, we've seen an awful lot of automation of builds. It used to be done manually, but now a lot of the builds are automated. We're also starting to see, and we see this in AWS, a lot of code being written automatically, or code being checked automatically with security application, security testing, for example. And so you'll see that trend, I think, continue to different industries. And you're already seeing, if you're a big Tesla fan like me, I've already got a Tesla Model 3. If you've ever seen one or driven one, you'll know that there's a lot of autonomous features. But I'm not sure it'll ever stop me driving my car. But yeah, we'll go through a transition, and what you'll see is the more commoditized skills, the ones that can be automated, will probably disappear, and then those people need to retrain and become maybe developers and move up the chain, maybe become machine learning experts. So yeah, that's sort of the path that I see. So I don't think the robots are coming just yet, and I don't think we're going to be losing all our jobs yet, but there will be a transition, and it will take time. And we've seen this with other ages in the past. So we've seen the age of industrialization, where we saw automation through steam, and then automation and empowerment through electricity, which is another phase. So I hope that answers your question. Great questions. Thank you so much for asking. That's all the questions. Wonderful. Let's go back and have a little look at how we're doing with our demo. The 25th of May, here we are. Yep, it's doing the model tuning now. Let me just talk through this little demo. So this is the same demo that I started at the beginning of this talk, but I used a no-code version. I used the experiment. This is how I can do it with code. And so this is a customer churn demo. So what I'm trying to avoid is losing my customers. It's very costly, and I want to identify my really unhappy customers. This is fictitious, by the way, and it relates to mobile phone plans. So the first thing I want to do is to set up my S3 bucket. That's my simple storage service bucket. It's basically where I store my artifacts, my source artifacts, and my outputs. And then I'm going to set up some code to set up some API calls. Again, this is all in that link that I posted. I'm going to import some Python libraries. we're going to download a synthetic data set, which is in a public S3 bucket, to our Elastic file system volume, which is over here to my left. That's my EFS or Elastic file system volume. It's just a file system, basically. Linux file system. I'm then going to inspect my data. And what I notice, if I look at it, that each line equates to a phone number. So that's my phone number. If I'm customer 0, then that's my phone number. I don't have an international plan. I do have voicemail. This is how many day minutes I use. This is my daily charge. And what we're trying to predict is that column at the end called churn. Is the customer I'm looking at likely to stay or go? And so churn true, he's likely to go. Sorry, this is actual data. So this is, yes, he went, he stayed, he went. And so this is real, if you like, fictitious data. And so we have our data set and it's labeled. So these are the labels effectively. We then want to divide our data set into what we call training and testing data sets. We won't cover the reasons for that, just accept that's best practice in machine learning. And we're going to upload the training and test data to S3. So all this code here took my data, popped it in an S3 bucket, and I've just done a bit of basic analysis on it effectively and set a few things up. Now the autopilot, so the Sagemaker autopilot demo that you saw when I opened, I'm going to show you in code now what you saw in the GUI. So the first thing we specify is we want to set up our target attribute, which is churn. We've already set up our buckets previously, but we fed them in here. And then we're just printing out what our input and output config is. And then this simple statement here, I'm just going to zoom in a little bit. Maybe a little bit small for you all. This is the actual autopilot code. So instead of using the GUI, I can just write this code, and it's AutoML job name that I'm interested in. And the create AutoML job is the actual function I'm using. So I specified the name, the input, the output, and the number of candidates. I specified 5. Remember, in the GUI, if you don't specify anything, the default is 250. Here you specify 20. And so what you would do, you just run these sections of code, and you can see it's repeatable. In code, though, I do have to track my autopilot job progress. So here's my progress here. So this is effectively the same or similar as what you saw here. In the GUI, it's automatic. It automatically displays it for you. In code, you have to tell it to display. And so this is one I've run previously. And so I can just run each field separately and generate the models that I need. It generates an explanatory report. It also generates some model insights. How we do with time? 6:30. Not sure this is going to finish in time. It's okay if it doesn't. It's actually taking a little bit longer than I'd hoped. That's okay. It generates 2 notebooks. If we get time, we'll explore the notebooks. And that's probably as much as I need to show you, I think, in this demo. Effectively, we get down to the bottom of this code and it will deploy the model, very similar to what you saw in the GUI. Now, what I want to do is show you one I prepared earlier. We haven't quite finished the previous model. And what you'll see is it did the same thing. I ran this a day ago. And what it did, it generated 5 models for me using 5 candidate pipelines. I can look at the data exploration notebook. Hopefully, if it comes up. There we go. Which will show me some basic statistics around. So some target analysis, the target label, was it balanced? Shows me a data sample. Were there any duplicate rows? It's doing some Pearson correlation. Was there anything in there that I need to understand from a data science perspective? This is all done automatically. Missing values, cardinality. These are feature engineering considerations that we need to think about to improve the quality of data and to speed up our algorithm. So if we get the feature engineering optimal, then the algorithms run much faster and we save money. So it's really important, especially on AWS, because we're paying as per minute effectively. And then if we close that one down and go back to here, we then have a candidate generation notebook. And this explains how the machine learning, what Autopilot did behind the scenes. So if I scroll down, again, you can run this for yourselves. Candidate pipelines. So it generated 5 machine learning pipelines that used 2 algorithms. And so this is one example. And this is the template that it used. So I can see the size of the instance type. I can see the name that was given to it. I can see quite a few things going on there. And if I scroll up, I just know that XGBoost is one of our algorithms. That was one of the algorithms used for this particular model. And you can see it's done some transformation. It using something called imputation. I'm not going to explain what that is, but anyone, if you've got data science background, you probably understand it. And one hot encoding there. So it's basically taking the data and transforming it in a way that means it runs more efficiently within the model, which produces the output faster. And the other thing you'll notice as well is it's picked the best model for me. If I scroll out a little bit, you see I don't know if you can see that, it's done that on what's called F1 score. So it automatically scores for you and it will pick the best model. Clearly, the more models you run, the more, probably the better outcome you're going to get. There is a break-even point, but by running lots and lots of models and letting it do lots and lots of experiments, it learns from the experiments and it gets better as part of the hyperparameter tuning. So the more candidates you run, the likely higher the scores, the better models you're going to produce. So that's why the default was 250. What did you run 250? But I don't really have time to run 250. But I would suggest if you're starting out with Sagemaker, start small, start with 5, 10, or 20 models, and just learn how the machine learning models work. We're almost there. So it's just generating reports and deploying the model. Now, if I go back to my original Sagemaker session, which is timed out, but I'll just come back in. Got a few new questions, I think. Yes, I've got 2 new questions. I'll address those, and then we'll start to wrap up, I think. So what I want to show you now, it says deploying model, didn't it? Yes, deploying model in here. So if I go to my main Sagemaker console now, which was the first screen that you saw. Oh, let's go into Sagemaker. What is in your opinion the most awesome ML or AI development application? Wow, what a question. To be honest, I guess what's impressed me the most with ML and particularly deep learning is probably some of the things that SpaceX have done with the autonomous rockets. I'm assuming, I don't know, that they've used some sort of machine learning, but the autonomous rockets landing back down, they've used automation clearly. And I mean, I would suspect it's machine learning or deep learning. And to me, that's probably the most impressive. Self-driving cars are pretty impressive too. So Celine, that's probably my take on that. And our customers are doing incredible things every day. I had a very large public sector customer looking at fraud detection and doing some incredible work. Huge customer and something you could never have done manually. It could only be done with machine learning. It was great to work with that customer and help them work through how best to deploy the different Sagemaker products and how best to get the most value from how to use those products. That was really exciting. That was when I was a technical account manager. Can't tell you the client, but it was an awesome client, awesome customer. How is Amazon SageMaker different from Microsoft Azure? So my suggestion is to try out Amazon SageMaker. So we have the broadest and deepest set of machine learning offerings than any other cloud provider. And we also develop new features at a faster clip than any other cloud provider. That's what I'll say. But I would suggest trying out Amazon SageMaker and let me know what you think. So I think we definitely have the broadest, deepest set of machine learning services. Cool. But thanks for your question. That was a great question. How are we doing? Right, we're back. Let me go into, yes. So this is our front end. And what I can look in here, I can look at inference. And I can look now at endpoints. And I should have an endpoint deployed. So today's date was the 25th of May, 2020. This is in UTC. So 8:36. You have to trust me that is correct. So that was created only 3 minutes ago. And so that endpoint is now running. So if I was to, I can serve API calls to that endpoint now, and it will service them and return a result. So I can feed in data via an API call if I wanted. I don't have that part of the demo here, but I could feed some inference data to it to say, hey, this is some new data, and I can do that in real time, and it would feed back in real time if I wanted, whether that churn was yes or no based on the data I fed it. So you can see you can do real time predictions with SageMaker, as well as batch as well. You can do batch predictions. So you can see there it's creating on the screen there, and that's a real time node. So I can do real time inferencing. So it's really important to remember when we're doing machine learning, different phases of the life cycle. So the first thing that you would do is prepare the data and label the data. So I'd already done that prior to this session. In fact, someone else had done it for me via the demonstration link. I then have to place that into S3 or simple storage service. And I then simply choose my parameters in SageMaker Autopilot, or I can do it through the Python code that you saw. And effectively, I create a number of candidates and generate a number of machine learning models. The tool then picks the best model for me and then deploys that as an endpoint. It's that endpoint that you run inference on. So training is the part where the heavy lifting and the heavy learning happenings around what's the best algorithm, what's the best tuning, and how we get the best model. And then we deploy that model, and then we run inference on it. And when we run inference on a model, it happens very, very quickly. So if you think about, again, I use the autonomous car as an example. The inference is the person driving the car. The model's already trained. The best model is then deployed into the car, or probably a series of models. And then the inferencing is what the driver is experiencing. So inferencing has to be very, very fast, has to be real time. Whereas the training can take many hours, days, or weeks, hopefully hours or days. And if you're doing things in parallel with something like SageMaker Autopilot, that can really reduce your timeframes. So I think one last time, I'm going to move back to the demo, and we pretty much finished. It's still deploying the model, but that's not bad. That's 5 candidates it's run, and it's managed to do that within 42 minutes. Clearly, if you're running a lot more, it would take a lot longer. And I think we're at time. That's 42 minutes. I think that's enough from me. Any further questions, please just reach out into the chat. I don't think there are any more. Let's have a look. Feel free to ask any questions, anyone. Let's have a look. No, I think we've answered everyone in there. I don't think I missed any questions, did I, Jeremy? I think I captured them all. I worked my way through them.
I think you have answered all of those questions, Paul. Okay, so Paul, are we still waiting for the last deploying model, or it's all done for the demonstration?
Yeah, it's not quite finished the last model. So have a look at the 25th of May. Still see it's deploying, but we can actually view the model here, and you can see it's creating. So
Yeah.
we've seen as much as we can see. I don't have code to actually run an inference against the model, but that will be the next step. I could develop some code and show the feedback it gives. But we're pretty much done from a demo perspective.
Okay.
But no, thank you so much for having me. I really enjoyed it. I hope your audience has enjoyed it. And if anyone has any more questions, feel free to pop them in the chat.
Yeah. So Paul, with that, I would like to thank you for joining our event. It was an amazing demonstration and sharing about machine learning and Amazon SageMaker. So for the rest of the participants, if you would like to learn more about Amazon SageMaker, so this session will be recorded. So we will actually post this session on YouTube. So feel free to just watch it again, or if you have any questions, maybe feel free to reach out to Paul as well. Okay.
Wonderful. That sounds really good. And Jeremy, yeah, if you want to send me a link to that YouTube, I'll make sure that I share it amongst our customers and AWS fans as well. So that would be fantastic.
Yep, will do. Thanks so much, Paul. Hope to see you again.
Absolute pleasure. Everyone, thank you so much. Everyone take care. Have a safe journey wherever you are. And I look forward to seeing you all soon. You take care. Bye for now.
Bye-bye. So for the rest of the participants, just would like to share what are the upcoming sessions that we have. Let me share my screen. So for this session, the next session, we have Trista Pan, who is the CTO and co-founder of SpearX. So the title of this session is From DBA and Open Source Contributor to CTO and Co-founder of Commercial Open Source Company. And we do have another session which will be running concurrently, which is by Dr. Mohammed, who is the founder of AIC for All. So this session, he will talk about machine learning and artificial intelligence. So feel free to just go through those sessions and just pick the session that you would like to join. And I'll see you in the next few minutes. Thank you.